The safest assumption in planetary science died in a matter of hours. In 1989, as Voyager 2 crossed the Neptune system at nearly 30,000 miles per hour, scientists were about to witness something that should not have existed. Rising above the frozen surface of Triton were towering black plumes of nitrogen gas blasting miles into space, bending sideways against a pale blue planetary horizon. And the problem was immediate. Because Triton was supposed to be dead. Not quiet. Not dormant. Dead. For decades, the outer solar system had been treated like a frozen graveyard. The rule was simple. Move far enough away from the sun, temperatures collapse, internal heat disappears, geology stops forever. It was one of the safest assumptions astronomy had. Then Triton erupted. And suddenly, that assumption was no longer safe. Before Voyager 2 arrived, Triton looked exactly like scientists expected. It was a small, icy moon orbiting Neptune nearly 3 billion miles from Earth. Surface temperatures sat around -390 degrees Fahrenheit. At that level of cold, physics seemed straightforward. Nothing moves. Nothing changes. Nothing has enough energy left to stay active. The models were comfortable. Outer moons this cold were considered ancient leftovers, frozen relics preserving the early solar system like untouched fossils. Voyager 2 was never expected to challenge that idea. The spacecraft had one job: perform a high-speed flyby, collect what data it could, and continue outward forever. There would be no orbit insertion, no second pass, no corrections. One chance. A few hours of observation. Then Triton would vanish behind the spacecraft permanently. And that made what happened next dangerous. As Voyager's imaging system turned toward Triton, cameras began sending back images of a strange pale surface covered in bizarre ridges and wrinkled terrain, unlike anything expected. Then analysts noticed something moving. Dark vertical columns rising sharply from the surface. At first, nobody trusted the image. Because the safe explanation was instrument error. A dead moon could not produce active eruptions. Not here. Not this far from the sun. But the next frames made the problem worse. The black plumes were still there. Several of them. Rising nearly 5 miles upward before suddenly bending sideways, stretched horizontally by Triton's thin atmosphere like black scars across an enormous frozen plain. The visual itself was disturbing. A pale pink world. Massive black columns shooting upward. Neptune glowing blue in the background. And absolutely no explanation that fit existing models. But this was where the real pressure started. Voyager 2 was moving too fast to wait. Every minute lost meant less imaging time, less data, less chance to verify what they were seeing. The spacecraft was already leaving. And scientists needed to know immediately whether the impossible had just happened. So attention shifted to the surface itself. If those black nitrogen plumes were real, something beneath Triton had to be generating enough energy to break through a crust colder than almost any place in the solar system. That should not happen. Extreme cold was supposed to shut worlds down permanently. Yet Triton looked active, not ancient, not fossilized, alive. And suddenly the geysers stopped being the story. Because the bigger problem was what those geysers meant. Planetary science had been relying on a hidden assumption. Temperature equals inactivity. Cold worlds become geologically dead. It was a rule used everywhere. Scientists used it when modeling distant moons. Used it when predicting internal oceans. Used it when estimating whether frozen bodies could sustain geological change over billions of years. That entire system quietly depended on one idea. Cold kills activity. Then Triton broke the rule in plain sight. The black plumes rising above the surface were no longer strange eruptions. They had become evidence that one of astronomy's most trusted shortcuts had failed. And Voyager 2 kept sending back worse news. The surface surrounding the plumes showed fresh terrain. Very few impact craters. Large, smooth plains. Signs the surface had been reshaped recently. Not millions of years ago. Recently, meaning Triton was not simply leaking trapped gas. Something inside the moon was actively driving geological change. At nearly the coldest temperatures in the solar system, the old prediction had fully separated from reality, and there was no time left to investigate further. Voyager 2 was already gone. No second mission followed. No return visit. No closer inspection. Humanity had captured one brief encounter and then permanently lost direct access. But the damage was done. Because those towering black nitrogen geysers forced scientists to rethink far more than Triton itself. If Triton could remain active at temperatures approaching absolute zero, then dozens of other frozen worlds suddenly became uncertain. Distant icy moons, once dismissed as dead, could be active. Hidden oceans became more plausible. Internal heat sources could survive far longer than predicted. Entire planetary models built around temperature thresholds became unreliable. And the image never changed. A frozen moon. Black plumes rising 5 miles high. A thin atmosphere bending them sideways. Neptune hanging silently behind it all. At first, it looked like an unusual eruption. Hours later, it had become something far worse. Proof that one of astronomy's safest assumptions had quietly failed. The outer solar system was never a graveyard. We were wrong about the cold. And Triton proved it first.